Okay, so we've now done heat fluxes and water fluxes. The next one we can think about is, what about the flux of carbon through the ocean surface? So of course we know on average the ocean is absorbing net carbon from the atmosphere, and indeed we were saying about 25% of the anthropogenic carbon is ending up in the ocean. And so how does it do this? Well, it's a turbulent flux, so it's exactly like the heat and moisture fluxes. And so we can apply the same sort of fixed law argument that we had before, except here usually you represent the concentration difference as a difference in the partial pressure of the carbon dioxide at the surface of the ocean versus the partial pressure in the atmosphere above. So it's this difference in partial pressure which forces the CO2 into the water. Otherwise, this is all really the same as we wrote before. Again, stronger airflow, more turbulence means you'll get a bigger flux. Wave-driven mixing plays a particular role here. So if you have breaking waves which entrain air, so air bubbles into the ocean interior, then that can enhance the air-sea fluxes of gases, including CO2. The only real difference in the formula here is that we have a dependence in this constant. This constant out the front does not just depend on the wind speed, it also depends on the solubility. So basically, if CO2 is more soluble in the ocean, then that will enhance the flux for a given difference in partial pressures. And this is quite important to the distribution of the CO2 flux at the ocean surface, because it turns out that, like most gases, carbon dioxide is actually less soluble the warmer the water is. And so you can see that plot here. So if you go from, say, the polar oceans through to the mid-latitude oceans, so say from 5 to 25 degrees, you can see the solubility basically halves. And what this means is that the flux is going to be much, much higher in the cold water regions. And if you look at a calculation of CO2 flux, such as from the IPCC in 2007, which is shown here, you can see that indeed the large fluxes into the ocean, quite large numbers, occur in the high latitudes. So you've got this region here in the Southern Ocean where you have particularly strong winds and cold water, and similarly in the north in these storm track type regions. In the North Pacific and the North Atlantic, you get these very large fluxes of CO2 into the ocean. By contrast, if you look at the low latitudes, you've got a significant outgassing. You've got a significant amount of CO2 coming out the ocean. So the net balance of all these is a flux in, but it's important to remember that most of that flux that goes in is happening at the high latitude oceans.